Welcome to the Web Security Bootcamp channel, a series of SQL injection tutorials. In this video, we're going to walk through a PortSwigger lab where we use SQL injection to examine and extract information from a database. Specifically, you'll learn how to list database tables and columns, a critical step in moving from basic SQL injection to real data extraction. This lab focuses on non-Oracle databases, where we can leverage the information schema to enumerate database contents. Before we begin, a quick reminder: everything demonstrated in this video is strictly for educational purposes. Only practice these techniques in legal environments such as labs like PortSwigger or systems you have explicit permission to test. Unauthorized testing is illegal and unethical. Let's get started. This lab contains a SQL injection vulnerability in the product category filter. The key detail here is that the results of the database query are reflected directly in the application's response. This makes it possible to use a union-based attack to retrieve additional data from the database. The application also includes a login function, and the database contains a table that stores usernames and passwords. Our task is to identify that table, determine its columns, and extract the stored credentials. Ultimately, we will use this information to log in as the administrator user and solve the lab. Now that we understand the lab setup, let's break down the attack strategy step by step. First, we confirm that the input is vulnerable to SQL injection. Next, we determine the number of columns in the original query. This is important because a union attack requires the same number of columns to work correctly. After that, we identify which columns can display text data in the response. These will be used to extract useful information. Once that's done, we move on to enumerating the database structure using the information schema. This allows us to discover table names and then the columns within those tables. Finally, we extract the user credentials and use them to log in as the administrator. First, I enable Intercept in Burp Suite, then click on the Pets category in the application. This intercepts the request, which I then send to Repeater. After that, I turn Intercept off so it doesn't block further traffic. I start by sending the request without any modifications to observe normal behavior. The server responds with a 200 status code, confirming everything is working as expected. Next, I test for SQL injection by adding a single quote to the category parameter. This results in a 500 error, which suggests the query is breaking. To confirm injection, I append a comment using $. This restores the 200 response, confirming that the category parameter is vulnerable to SQL injection. Now, I determine the number of columns returned by the query. I use a union select statement with 2 null values and send the request after URL encoding the payload. The server responds with a 200 status code, which indicates that the query has 2 columns. To verify that both columns can handle text data, I replace the null values with simple strings like A, B, C, and D, E, F. After sending the request, I again receive a 200 response, confirming both columns are suitable for data extraction. Next, I identify the database type and version. To do this, I open the SQL injection cheat sheet, which provides database-specific syntax for different systems. This is especially useful if you're not sure which database the application is using. Since this lab isn't using Oracle, I start testing other common databases. First, I try a Microsoft SQL Server specific payload using doublet version. However, this results in a 500 error, so I can rule out a Microsoft SQL Server. I then move on to a PostgreSQL and use the version function. This time I receive a 200 response, which indicates the payload is valid. Now I can inspect the response to identify the database version. By inspecting the response, I can see that the database is a PostgreSQL version 12.22. If you want a deeper explanation of how to find the number of columns or identify the database version, I've covered those topics in detail in other videos. For now, let's continue with the next step of the attack. We're continuing our testing, and now we need to prepare the payloads for the next steps. I'm going back to the SQL injection cheat sheet to the database contents section. Here I can see that for PostgreSQL databases, the list of tables can be retrieved from information schema tables, and the list of columns from information schema columns, typically filtered by the table name field. Next, I briefly consult the official PostgreSQL documentation to better understand these system views. In the Tables section, the key field is table name, which represents the name of each table in the database. In the Columns section, the important field is column name, which represents the name of each column. The table name field also appears here, allowing us to determine which columns belong to a specific table. At this stage, I'm not searching for the actual table or column names yet. Instead, I'm identifying the metadata fields that need to be used in our SQL queries. Using these metadata fields, we can construct union-based queries that allow us to retrieve the real table and column names from the application's response. To enumerate tables, we select the table name field from information schema tables. This allows us to retrieve the names of all tables in the database. Once we identify the relevant table, typically the one containing user credentials, we then enumerate its columns by selecting the column name field from information schema columns. After discovering the actual table name, such as users A, B, C, D, E, F, we substitute it into the where clause of our query to retrieve the corresponding column names. If you'd like to better understand how these payloads work, I recommend watching a couple of short videos, How SQL Queries Work and Union Attacks Explained with Examples. I'll leave the links to these videos in the description. Now, let's return to testing the application and start applying these payloads in practice. I'll start by modifying the payload to enumerate the table names. Single quote union select table name, null from information schema tables --. I send the request and receive a 200 OK response, indicating that the query executed successfully. Next, I use the search bar to look for the word users, since we expect the credentials to be stored in a user's table. In the response, I find a table named users WGGOFV. I copy this table name and save it in a notepad for later use. Now that we know the table name, we can enumerate its columns. I modify the payload as follows. Single quote union select column name, null from information schema columns where table name users WGGOFV --. After sending the request, I again receive a 200 OK response. Using the search bar, I look for the term username. On the screen, I can see the columns username and password. I copy these column names and add them to the notepad. With both the table name and column names identified, we can now extract the actual user data. Now I update the payload by inserting the table and column names we just discovered. I send the request and receive another 200 OK response. To quickly locate the administrator's credentials, I use the search bar and type administrator. Here I can see the administrator username and just below it, a value that appears to be the corresponding password. I copy this password. Next, I return to the main application and navigate to the My Account page. In the username field, I enter administrator, and in the password field, I paste the value I. After clicking Login, I successfully access the administrator account. Finally, the application displays the message, "Congratulations, you solved the lab," and confirms with the text your username is administrator. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.